We've been finding missing side lengths of right triangles. And so what happens if I'm asking for the measurement of the angles of a right triangle? That's what we need to move into now. If I asked you to solve for the length of segment MN, how would we do that? Yeah, say it louder, the Pythagorean theorem. Pythagorean theorem, right. So let's go ahead and everyone do that. Determine the length of segment MN. What we are doing is solving this right triangle. When I say solving, that means you tell me every single angle measurement and every single side length. So since we've got two of them, we can use Pythagorean theorem. What variable are we searching for using Pythagorean theorem? C, which represents the length of the hypotenuse. So I'm going to leave C as is, but plug in 15 and 7 for the length of the legs. I'm going to plug that into my calculator rather than individually doing it, stating 225 plus 49. My calculator can do that for me. So 15 squared plus 7 squared equals 274. What do we need to do next? Take the square roots. So I've got C is equal to the square root of 274. That number is even, so it's divisible by 2. After you do that, you get 137. Pretty sure 137 is prime. And did anyone else find a value that fit into it? Alright, cool. So we can simplify it. The most simplified radical is this. C is square root of 274. And so I asked for the length to be a radical. Length to be radical. Now comes the new stuff. We need to figure out the measure of angle N and the measure of angle M. This is the square root of 270 what? 4. Okay, cool. Always use what is printed on the piece of paper. Always use what is printed on the piece of paper. I understand that we just found the length of segment MN and that we all agree, we know it's the right answer. It is the square root of 274. But just please use what's printed on the piece of paper when you're trying to solve for any other angle measurement or any other side length. Always use what was given to you. Let's solve for the measure of angle M first. In order to solve for the measure of angle M, we're going to approach this problem just like we have been using trig functions. So let's see what we know. We're searching for angle M, and I'm going to label the sides accordingly, like we have been with the opposite, adjacent, and hypotenuse. Well, this is my opposite side, and this is my adjacent side. And we solved for the hypotenuse, but we're not going to use that value. So we're going to focus on the opposite and adjacent leg because that's what was printed, that's what's given. So if I want to write a trig ratio using these values, the measure of angle M in 15 and 7, what trig function involves opposite leg and adjacent leg?
Tangent.
Tangent. So we're going to just approach this the same way. I've got tangents of the measure of angle M. And we're going to write is equal to trying to find some good space to work with. And then go ahead and write your ratio. What's my ratio going to be? Tangent of measure of angle M is equal to what? 15/7. Okay. When we're trying to solve for an angle measurement, meaning this is our variable, we need to get that by itself. Well, currently, bless you. Currently, what's happening to our variable, the measure of angle M, is that we're taking the tangent function of it. And so we need to do the inverse operation. We need to do the inverse operation. There's a symbol that we use in mathematics to denote the inverse operation. And it is the exponent -1. This is why. If I have just some value, like x, well, it's currently being raised to the first power. We don't ever write that, but it's understood that there is a +1 coefficient and that it's being raised to the first power. We don't write either one of those, but it's understood. Okay. Well, the inverse of this value is denoted by raising it to the negative first exponent. Now in Algebra 1 you were taught negative and positive exponents. Does anyone remember how we can rewrite this using positive exponents? Or what does a negative exponent mean? Do what? So it's not the opposite reciprocal, but we do put, if it has a negative, then that goes to the denominator with that same power. Okay, so maybe in Algebra 1 you had x squared y to the -3 z to the 4th or something like that. This could be written as x squared c4. Those are positive, so they stay up, and then that y to the 3rd power, we can positive it down to the numerator. So we've seen this stuff before. Well, I can represent this value, x over 1. And so if you take the product of these, they're inverse functions, they would just reduce down to 1. They would cancel each other out. So we use this symbol of -1 to represent the inverse functions. We'll get into that for pre-cal and lots of calculus, inverse functions, hopefully in Algebra 2 as well. So right now our variable, the thing that we don't know, what's happening to it is we're taking the tangent function of that variable. So we need to do the inverse operation to both sides of the equation. So I need to use the inverse function of tangents, and that looks like this. You write tan just like normal, but then now we add this -1. And this denotes that we're taking the inverse. And we have to take the inverse tangent of the entire left-hand side of the equation. And whatever you do to one side of the equation, you must do that to the other. So in red ink is me taking the inverse trig function on both sides. What's left in black ink was the original left-hand side and the original right-hand side. Now mathematically, inverse tangent and normal tangent Those are inverse operations of one another, and that's why they, for lack of better terms, they cancel each other out, and we're left with the measurement of angle M all by itself on the left-hand side. And then on the right-hand side, I have the inverse tangent of my ratio. I have the inverse tangent of my ratio. This is my exact answer. The measure of angle M is exactly the inverse tangent of 15 divided by 7. Now, let's take a gander at our calculators and see how our calculators play into this. Okay, what is this? Okay. Now, if you look at the secondary functions, what's written in blue ink on your calculators, the secondary functions, above the normal sine, cosine, and tangent buttons, in blue ink above those you will see the inverse functions. It has the same 3 letters, but then has that, they're raising it to that negative first power, and that denotes it's the inverse function. It does the opposite. So we're going to type in our exact answer into our calculator using the same exact notation here. So I first must hit second to go into the secondary functions, and then hit tangents, and then you'll notice that the calculator adds in that -1. And then you will type in your ratio. So the calculator did that for us because we hit the second first. It did that inverse function for us. And then you write in whatever ratio according to the diagram. And then press enter, and it spits this out. We're going to round to the nearest tenth. Whenever you are told to round to the nearest tenth or hundredth or whatever that placement is, you have to represent that place value if they ask you to. So, I currently have 64.98. What happens to the 9?
It takes the other 65.
It goes to the next value, which is 10. So that's why this is a 0, and then it adds a 1 there. So this is truly 65 when you round to the nearest 10th. But if they ask you to round to the nearest 10th, you have to represent the 10th place, even if it is a 0. So the correct answer, rounding to the nearest 10th, is 65.0. You must represent that 10th value place. So yes, it is 65.0 will be my rounded answer. And so I'm going to stick with that same notation. That my exact answer is in box, and then my rounded answer is circled, rounded. Okay? Please make sure you get in the habit of putting your units. This is degrees. Angle measurements are in degrees. All right, we're gonna set up our